All right, so introducing Chapter 3, Section 10, Chemical Reactions. How are we going to write these and balance them? So the first question you might say is, writing these questions, how am I going to know what to write? Right? So the question might say something like, write a balanced equation for the combustion of methane. All right, so you need to think to yourself, all right, what is combustion? So first of all, I've got methane here, right? CH4. And I'm going to be combusting it, okay? So the definition of combustion is combination with oxygen, right? And if you're combusting hydrocarbons, you're going to be making CO2 and water. Okay, so that's the first thing that you do, is you've got to say to yourself, what is meant by the term combustion, right? And so I'm starting with methane. And that's what I've got, methane and oxygen. All right, so you've seen combustion a couple times. This is just an example. All right, so the next thing you need to do is you need to say to yourself, all right, if I'm going to balance this, it must mean that I've got the same number of carbons in the beginning as I do in the end, and the same number of hydrogens in the beginning as I do in the end, and also oxygens, right? Okay, so let's do that now. Write it down here, make some notes. Plus O2 produces carbon dioxide and water. All right. So if I've got carbons, if I'm generally going to go left to right. Oh, by the way, so Tro recommends, and I think it's a great idea, to always take the elements that are by themselves. What does that mean? By themselves, okay? You see that? Oxygen's by itself. He's going to say do those last, all right? Otherwise, we're going to go left to right. So let's do here. CH4, it's got one carbon, and that's got one carbon. So we're good with carbon, okay? Now let's do hydrogen. Hydrogen, there's 4 hydrogens here. And how many hydrogens are over here? 2, okay? So if we do that, then the hydrogens are taken care of. All right, and then finally, oxygens. I've got 2 over here and 1, 2, 3 over here. Okay, so in order to make this 3, I can do 3 halves, right? And that'll give me 3 atoms of oxygen over here and 3 over here. By the definition of balance, it's often going to be small whole number coefficients. Okay, so 3 halves is not a small whole number coefficient, but I can make it a small whole number coefficient if I multiply everything by 2. So before I do that, let's make sure we got everything right. Okay, so carbon, it's 1 and 1. Hydrogen is 4 and 4. That's good. And oxygen is 3 halves of 2 is 3. And 1, 2, and 3. So oxygen's good too. Okay? Now, in order to make small whole number coefficients, I just take the denominator of that number there and multiply everything by that, right? So it would be CH4 plus 3O2 produces 2CO2 plus 4H2O, okay? Whoops, whoa, crud, I lost all my notes too. All right, so lost all my notes there. You know what I'm gonna do? I'm gonna write it out again. I had CH4, I'm gonna do it a little faster this time. CO2 plus water, okay? Carbon is 1 and 1. Hydrogen is 4 and 4, okay? Oxygen is 2, and it's 1, 2, and 3 over here. Oh, whoa. 1, 2, 3, 4. Sorry. Wow, I bet you caught that on my last one. So watch this. 1, 2, and then 1, 2, and then 3. See, there's 2 over here, right? It's a good thing so now it's 4 and 4. Good thing I made that mistake. So it's a good thing I accidentally advanced that slide, because I would have made that mistake. I might have caught it. Who knows? CO2 plus 2H2O. I realize that's the same number I got up here. Let's just check it finally, okay? Carbon is 1 and 1. Hydrogen is 4 and 4. And oxygen is 4. And then 2 oxygens over here and 2 here, right? 4 and 4. Okay, so that's good. All right, it's a good thing I did advance that slide on accident. Okay, so let's look now at an example. Oh, I'm sorry, a couple details here. First of all, the margin note on page 105. Margin note on page 105 says we cannot change the subscripts when balancing a chemical equation because that changes the molecules themselves. Changing the coefficients simply changes the numbers. All right, so let me give you an example of that. C2H6 plus O2 produces CO2 plus water. Okay, it's another combustion reaction. Can you read my writing? Combustion. Specifically, this is ethane. All right. So what we would do here is we would say 2 carbons and a carbon here. What would be a wrong thing to do? There's only 1 over here and 2 over here. What would be wrong is to change that, right? You see that? Because CO2 is carbon dioxide. CO2 is carbon dioxide. C2O2 is not carbon dioxide, right? So if you know for sure that combustion makes carbon dioxide and water, you can't do that. Best you can do is change that. That's not the best, it's the perfect thing to do, is to change the coefficient. So again, the margin note on page 105 says we cannot change the subscripts when balancing a chemical equation because that changes the molecules themselves, right? That's not CO2 anymore, or it's not carbon dioxide anymore. Changing the coefficients, simply changes the number of molecules present, okay? And then the second thing I want to point out is that the states are all oftentimes given. And that is, if it's a gas, it's given as a G, liquid given as an L, acid is given as a solid, and aqueous is given as AQ. All right. Okay, so let's do an example, and I'm going to keep this in mind too as I go this time. You ready? Equation or example 3.1 or 3.20, and this is on page. This is in your textbook on page 109. Page 109. Write a balanced equation for the reaction between solid cobalt-3 oxide and solid carbon to produce. All right. So first of all, we've got to start here. Write a balanced reaction. This is a very common way that the question is given. And what we're supposed to do is write a balanced equation for the reaction between solid cobalt-3 oxide. All right. So first thing I'm going to do is I'm going to say cobalt. I looked that up. And it's cobalt-3, right? And oxide, which is 2 minus. And so in order to make a compound between these two, I'm going to have to multiply this by 2 and that by 3, right? Can you see the lowest common multiple is 6? So here's solid cobalt-3 oxide. The 3 stands for the charge on here, by the way. That 3 right here stands for the charge on that cobalt, not necessarily for the 3 that goes here. And this is a solid, right? Oh, crud. Okay. So I lose my notes when I do it like this. Okay, so let me go back. It's right? That solid is here. And the cobalt-3 is here. Okay. And solid carbon. And carbon is elemental. Okay, can you see the solid here? To produce solid cobalt plus carbon dioxide gas. Can you see that? Carbon dioxide gas. All right. Now, I need to make sure this is balanced. So this cobalt, there's 2 cobalts over here and only 1 over here. Cobalt's by itself here, so I can do that last. Carbon's also by itself. So it looks like oxygen and cobalt, or oxygen is the only thing that's not ever by itself. So let's do oxygen first, okay? So if there's 3 oxygens over here and 2 over here, what's the lowest common multiple of 3 and 2? Looks like I'm going to have to put a 2 here and a 3 here. Can you see that there's now, for oxygens, there is 6 over here, right? And can you see that there's 6 over here too? Okay, so that's even. All right, now let's go to cobalt. If there's 4 cobalts here, I'm going to have to put a 4 here. Cobalt's done. And oxygen is done. Now carbon, right? It looks like I've got 3 carbons here, so I'm going to have to put 3 here. So carbon is done. So the answer is 2CO. You know what? That's messy. 2 cobalt, O3, solid, plus 3 carbon, solid, produces 4 cobalt, solid, plus 3 CO2 gas. Okay, wow, this is kind of complicated. So it's a good thing we have some systematic approach for this. This is the answer. Let me just look at my book real quickly and verify that. It goes to 2, 3, 4, 3. That's what I've got. Okay, very good. Let's do another example. Example 3.21, which is also on the same page, I think. 3.21 on page 109. Write a balanced equation for the combustion. All right, so if it's combustion, it's going to be something combined with oxygen of butane, C4H10. There's the state, combined with oxygen gas, to produce carbon dioxide plus water. All right? So if that's the case, I'll put my states here. All right, let's see if I've got my states, some hint that's given for my states here. The hints that's given for my states, look at this, gaseous butane. That's gaseous. All right. And of course, oxygen is gaseous, which combines to form gaseous oxygen. Okay. To form gaseous carbon dioxide and gaseous water. Okay. So there's the reaction that's written out. Now I've got to balance it. All right. So I'm going to go left to right, but I'm going to take the element that's by itself and do that last. Left to right. So 4 carbons and 4 carbons. Boom. Boom. Now, hydrogens, 10, and I can make that 10. You see that? So, 10 and 10, 5 times 2, right? Okay, the last thing I'm going to do is oxygens now. So how many oxygens do I have over here? Well, just 2. Over here I've got 8 plus 5 is 13. So if I'm going to make that even, I'm going to say 13 halves because there are 2 of them, right? See 2 oxygens in there? 13 halves. Then the last thing I'm going to do is I'm going to say, all right, well, that's not a small whole number ratio. So I'm going to multiply everything by the denominator here, and it'll be good. So this ends up being 2 C4H10 gas plus 13 O2 gas produces, everything multiplied by 2, 8 CO2 gas plus 10 H2O gas. Okay, and there's my answer. You know what, let's go through and check one more time, okay? There's 8 carbons over here and 8 over here, okay? How many hydrogens? 20? 20 over here, and 2 times 10 is 20, okay? Now oxygens, 26 over here, see 13 times 2, and this is difficult, okay? That's 16 over here plus 10 equals 26. Okay, so this is my answer. And we're done with example 13.21. I think I have one more example here, 13.22. It's a little more complicated. Write a balanced equation for the reaction between aqueous strontium chloride. Okay, so I'm going to take strontium chloride, and I'm going to look up strontium, because there's no Roman numeral here, okay? So I'm going to look up strontium and I'm going to find in my periodic table that strontium is in the second column. So it's 2 plus. And chloride is 1 minus. So it must be that there are 2 chlorides to balance for that strontium. And it's aqueous. Plus aqueous lithium phosphate. So I look up phosphate. This is on page, I think, 91. There's a table, table 3.4. You've got to know this table, table 3.4. And we find that phosphate is PO4 minus, 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 3 minuses. And lithium is in column 1, so it's lithium plus 1. So lithium phosphate is going to be Li3PO4. Okay, that's going to be the compound. It's aqueous. Okay, produces solid strontium phosphate, all right? Strontium, okay, now phosphate again is PO4 3 minus, and strontium is 2 plus, right? Because it's in the second column. So this is going to have to be strontium 3 phosphate. There's going to have to be 2 phosphates, right? Because that was 3 minus. And so the lowest common multiple of 3 and 2 is 6. So it's going to be 2 of those. And it said this was solid plus aqueous lithium chloride. Okay, so lithium is plus 1 because it's in column 1. Chlorine's minus 1 because it's in column 7. Right, we knew that was that, and we knew this was plus 1 and minus 1, lithium chloride. All right, and it says aqueous lithium chloride, so I'm good here. Okay, so that's the reaction, but now we need to balance it. So let's go left to right. I don't see anything that's by itself, but I do see some phosphates here. There's phosphates. There's 2 phosphates here and only 1 phosphate here. 1 strontium chloride, 3 over here. So I'm going to go, let's go left to right. 3, and so my strontiums are done. Chlorine, 2 here, and only 1 here. So let's do lithium like that. So there's 2 chlorides here, and 2 chlorides here. Now lithium, 3 here. Okay, this is going to be complicated. All right, so lithium is 3 of them here, and 2 here. So there's going to be some common multiple. So this is going to have to be 2 and 6. Right? Oh, wait a second. It's a good thing I did that. Whoa, look at that. There were 6 chlorines. I'm not sure how I missed that. Okay. You know what? I'm going to start over again. There's a nice thing about balancing is you can just loop back over and over and over again, and it's really okay to start over again because all you're doing is counting the sum, okay? And I'm going to say lithium chloride here, okay? I know I put that coefficient here, but let's start again. Strontium is 3, okay? So now chlorine 6. Yeah, that was my mistake. So there's 6 chlorides here, and so I'm going to have to put a 6 here. Right? Now, there's 6 lithiums. Okay, I did strontium. I did chlorine. 6 lithiums. 6 lithiums. Oh, chlorines are done. Phosphates. I've got 2 phosphates. And 2 phosphates. Wow, done. Okay, so one last time. Let's make sure that, let's say the number. There's 3 here. And 3 strontiums. Chlorine, there's 6, or chlorides, I should say. There's 6 and 6. And let's see, lithiums. There are 6 and 6. And phosphates. Can you see that there's 2 phosphates? 2 and 2. We're done. That's it right there. Okay. All right. So I think that's it for writing and balancing chemical equations.